This is another potentially new area of research for us which we're planning, and I'm going to describe what we're going to be doing. It's focused very much, as Karinchi has said and other speakers today have said, Rahul himself, about trying to improve early liver function, allow us to use organs where we have in the past been worried about early function, and to be able to kind of boost their early response in the body. So I'm giving the talk, but actually it's the whole team that's going to be involved and has been involved so far in the planning. Okay, we do need a little bit of biology and chemistry. As Professor Davidson keeps indicating, it's been a few years since my school days and my chemistry, but I do remember the extreme power that oxygen has, and this really is all about oxygen, what we're trying to do. It really is the life force. Okay. It has helped us evolve, as many of you know. And if you're interested, a friend has written a book about the importance of oxygen. I'm not here as a salesman, but if you're interested in some accessible information, then he's called it the molecule that made the world. And it's the molecule that makes our livers function as well. So if you're interested, then by all means read the book. But as with many good things in life, there's no trade-off, there's no free lunch. Oxygen use, ability to use that incredible energy comes at a price. And we've heard about the importance of the liver several times today. It constitutes only 2 to 3% of the body weight. But when I went back and looked at my old physiology books, it even surprised me to think again that actually this organ uses 20 to 30% of the oxygen that we take in. That's about the same amount of oxygen that our brains use, and we all know about the importance of oxygen to our brains. If we're watching Holby City and there's an accident, people run in with oxygen cylinders to support the brain function of patients, which is very appropriate. But our livers actually tend to use as much oxygen as the brain, so it is a really important energy-using organ in the body, and that energy is used to keep us healthy. This is a cartoon I've taken from I think the British Liver Trust. We've heard from them today somewhere out there about the fact that the liver is our factory. It does so many different things. This is my slide of the factory. You don't need to look very closely at what's going on. It reminds me of my grandfather taking apart watches. There are cogs turning all the time within the function of our liver, and these are all the chemical processes, and we don't need to read them, but all interacting ongoing. And it's not only one slide. If we put 20 of those images on top of each other, that's about what our liver is doing all the time that I'm standing here talking to you. And they use this large amount of energy to keep all of this functioning and organised. We've heard about organisation from Sanjeev. To get the energy out of oxygen, our livers have to push chemistry to the absolute limit. To strip the energy out, and if everything goes well, to take the energy and leave parts of the molecule which makes water. A very sort of harmless molecule. But it is almost like splitting the atom. And we all know about the problems of atomic power, and it's almost the same in biology. There are situations where things don't work absolutely efficiently. And this is an image of a power station you're well aware of. These are the power stations of our liver cells, or indeed all of the cells of our body, the mitochondria. And we talked about liver cells. This is an image of one liver cell taken out of the body. It's possible to do that. And here's the cell all around with the cell nucleus and the genes impacted. And all of the little dark spots are these energy powerhouses, the mitochondria. So that's how we use the energy, the oxygen energy, when our liver's functioning well. The problem is, as Karinchi was just saying, taking the organ from a natural situation and putting it into transport and cold storage upsets this control and this balance. In the process of getting the energy out of oxygen, Normally things are well organised, but if things go a little bit awry, we have a process called free radical production. This is a cartoon where this is actually an oxygen atom, and it's made of different parts, electrons and protons. And if an electron happens to drop out, you're left with a very, very active chemical called a free radical. And this happens when we lose control of oxygen in our liver. And normally our liver cells, in fact all of our body organs, mop up free radicals by antioxidants. Again, you've all heard about antioxidants. We read about it in the newspapers and the media every day. My grandmother always used to tell me about eating sort of healthy diets and fresh fruit and greens. And it's absolutely true. We all know we should be doing that all the time. We do need to replenish our healthy antioxidant systems. And the antioxidants sort of interact with these dangerous chemicals by giving them back the electron. So they pair up and they neutralise the free radical. It keeps us healthy in youth and in old age. The point is that in liver transplantation, we put in the new liver, and we need that new liver to function really fast, really quickly at the point when the process, the transplant operation has been performed immediately. But if we're thinking of taking in antioxidants from food and diet, it's going to take too long. We don't have enough time to accumulate the antioxidants in the liver right at the moment when it's needed, when Professor Davidson has performed the operation. There are some fast-acting antioxidants which are based on sulfur, which is a chemical and which is part of the antioxidant process. And these can be dissolved in water and delivered as a drug. And at the moment, we've been using one particular type of sulfur antioxidant called acetylcysteine. And here you can see the sulfur, the S group on acetylcysteine. But in the recent past, we've become aware and started to work with colleagues in Japan and in America who have access to another sulfur antioxidant called butylamine. And it appears to be clinically safe because it's been used in Japan for many years in rheumatoid arthritis. And it's got twice as much of the sulfur antioxidant power, and it's got these other little molecule side branches on the chain, which means it gets into the cells very quickly. So what we want exactly is some antioxidants into the liver cells very quickly at the time we need them, when the liver is being transplanted and needs to function well. So where are we right now? Well, as we've heard today, we need appropriately to go through various levels of regulation for safety and efficacy before we start a clinical trial. And right at the moment, our plans are being looked at by the Medical Research Council and the Medicines and Health Regulatory Agency to ensure that they are happy with what we're doing. We're going to be working as two centres, the Royal Free in Leeds, and from my own perspective, this is again a really positive way ahead for the UK liver transplant community by acting as groups within different centres, not trying all the time to compete against each other, but by actually working together on these types of trials and sharing information very much more freely. So then, of course, we will be explaining to the patients with our liver transplant coordinators and asking for consent to join the trial if they wish to do this. And we've heard today about having appropriate trials that allow us to make clear assessments without prejudging things. So we have to randomise the patients within the trial receiving the antioxidant or not, and we have to make sure that we don't know which patients are which. There's a code which can be broken later, and we can identify the results. And then a dose of butylamine will be introduced into the liver blood supply of the new liver as soon as it's transplanted, so right at the point of surgery. And then a lower dose is planned to be given into the intravenous fluids, which are normally part of the transplant process, as you know, in the early hours post-operation. And then this information is going to be analysed by the clinical trials units both at Royal Free and UCL and in Leeds. So we're very enthusiastic and pleased that we're in the state where we can look to the future and try and identify new ways in machine perfusion or this type of antioxidant therapy to help improve the early function of the transplanted liver. And we hope that it will be important in liver transplantation. And if it's important in liver transplantation, it could be important in other areas of liver disease and in other transplants such as kidney. So there's an opportunity to spread this widely across the transplant community. Okay, thank you very much.